Good evening, my name is Imani Richardson, and my presentation is on urban runoff and the decline of water quality. Urban runoff, what is it exactly? Urban runoff is also known as surface runoff, storm runoff, and non-point solution, an EPA umbrella term. Typically, as an area becomes urbanized and covered in non-pervious material like tar, asphalt, and concrete, its infiltration abilities are reduced, increasing the collection of surface water and pollutants. This water then flows into streams, estuaries, lakes, and other bodies of water, carrying the pollutants with them. Urban runoff is a precipitation event which carries pollutants from surface areas as a result of urbanization. These pollutants can come from rooftops, storm drains, gutter, pet waste. It can come from your lawns. It can come from vehicles and driveways and many other areas. The image here is a depiction of an urban area. Let's imagine this is Miami after heavy rain. 30% of surface water from the precipitation event returns to the atmosphere, while the majority remains here. There's only a possibility of infiltration of about 15% because of the non-pervious surfaces in the city. You may wonder why more of this water does not dissipate into the atmosphere through evaporation. This is because the collection of water begins moving almost immediately to other bodies of water. So as we can see here in the image, 30% of the water evaporates, and then 55% of the water begins traveling towards streams or, traveling along probably storm drains into other bodies of water. And this is where the infiltration would typically occur in this area, but because of the non-pervious, or for the most part, non-porous material, which doesn't allow water to really seep through into the ground water table, it actually just maintains itself at the top. So the public health threat. Urban runoff is one of the leading sources of water pollution in streams, lakes, rivers, and reservoirs. According to a federal report, pollution from urban runoff can include heavy metals, dirt, salt from roads, pesticides, and fertilizers from lawn and gardens, and oil, grease, antifreeze, and other toxic chemicals from vehicles and vehicle maintenance facilities. Pollutants that can be found traveling in urban runoff are pollutants, as mentioned before, like oils, toxic chemicals, sediment, nutrients, and road salts. According to research conducted by the EPA, sediment constitutes the largest mass of pollutants in urban runoff. It increases turbidity, which is the cloudiness or haziness in water caused by large numbers of particles that are invisible to the naked eye. Turbidity measurements is a key part of water quality testing. Sediment can also carry toxic chemicals, nutrients, and thermal pollutants into bodies of water. The primary source of sediment comes from construction and construction sites. The effects of sediment will be highlighted further in later slides. Excessive nutrient deposits like nitrogen and phosphorus can have a negative impact on waterways. Although they are a part of the aquatic environment, excessive amounts of these nutrients can lead to increased algae growth and eutrophication, stimulating growth of plant life, resulting in a depletion of dissolved oxygen, suffocating other marine life. So an example of this would be algae blooms. Hydrocarbons, or petroleum-based products find its way into runoff from parking lots, convenience stores, gas stations, and pretty much the street, in addition to more areas. These hydrocarbons can produce toxic effects in marine life and bioaccumulate up the food chain. In urban runoff, there are concentrations of fecal coliform bacteria. Oftentimes, its presence exceeds the threshold for human contact, increasing each time from storm to storm. Common waterborne pathogens present in runoff are Giardia and Cryptosporidium, which can lead to intestinal infection, potentially causing life-threatening problems. Fecal sample testing can confirm the presence of the gastrointestinal infections. So here's an example of sediment, as mentioned earlier, and this example is highlighting the impacts of suspended sediment, which is sort of like that turbidity, where we talked about the cloudiness, which is something that's being suspended. So suspended sediment can cause abrasions in fish gills, increase in risk of infection and disease. It can cause a loss of sensitivity and threaten certain fish species. Also, it reduces sight and distance for certain types of fish. Examples are trout. And it reduces light penetration, causing a reduction in plankton and aquatic plant growth. So it affects photosynthetic abilities in plant growth. And here's an example of deposited sediment. Of course, it reduces the survival rates for fish eggs, as well as it smothers the aquatic insect community, and it also causes destruction to spawning areas for fish. Deposits also diminish scenic and recreational values of waterways. So imagine a beautiful lake or stream that you previously visited, maybe when you were hiking, and with an increased amount of sediment, the aquatic life degrades, and you no longer see the fresh algae or different things in the area. The plant life begins to decline and the fishes reduce in numbers. So here's an example of the toxic chemicals that can be found in urban runoff. A lot of these chemicals we're familiar with, and some of these chemicals we aren't. Acetone, for example, most of us are familiar with. It's a chemical that is used for nail polish removing. And ammonia is a household cleaner that in large amounts can lead to death. Arsenic, which is highly toxic in its organic form and a great threat to public health, can disrupt metabolisms at the cellular level. Cadmium can accumulate in shellfish in concentrated levels, posing harm to people who eat them. Lead, for example, is a persistent organic pollutant like dioxin, which can bioaccumulate, passing from one organism to the next organism, leading to impaired brain functioning. Another chemical on the list, which is PCBs, polychlorinated biphenyls, I believe I pronounced that right, which travels up the food chain, similarly to dioxin, travels up the food chain, can disrupt thyroid hormone levels. It can lead to cancers, harm your immune system, and it can affect your nervous and reproductive system in both humans and animals. Changes in hydrology. With urban runoff, it actually can change the shape and flow of waterways because of its flow through piping systems. So when the urban runoff first leaves the city area and it flows down into the sewage system, and as the water increases, the level of water increases, it flows at a higher rate. And sometimes this causes a change it actually causes widening of some channels, as well as also another effect of urban runoff is the lowering of the water table. And you may wonder what that is. So in a previous example, when we first went up to the image, let's go back. Remember here when we discussed that 55% of the water that comes from precipitation is actually, flows down into rivers and streams, and 10% doesn't really, well, at least 10% flows into infiltration. So what this means is, if this was a groundwater area or aquifer, typically the rainwater, the earth filters it and it flows into the aquifer. With non-porous sites like this in a city area, water isn't able to flow back in, so it's not being replenished. So eventually this water table keeps decreasing and decreasing, which is where we end up with sinkholes and landslides. So the EPA has a set of best management practices. The best management practices include 6 areas: public education outreach, public involvement, illicit discharge detection and elimination, construction site stormwater runoff control, post-construction stormwater management, and new development and redevelopment, and pollution prevention or good housekeeping for municipal operators. In order to combat runoff, the EPA developed these 6 control measures. In public education outreach on stormwater, the EPA provides guidelines to provide education to everyday individuals, highlighting behaviors like littering in order to promote healthier waterways. Education through this practice aims to convince others to change their behavior, reducing waterway pollution. And public involvement encourages a collaborative effort to working towards the same goals. Public involvement encourages a collaborative effort in working towards the same goals, spreading the message of stormwater pollution prevention, highlighting activities of pollution and actions to restore waterways. Illicit discharge detection and elimination aims is to reduce illicit water discharge, as is specifically stated, since stormwater cannot be treated like wastewater. So in sewage systems, they run through a treatment facility, but in stormwater, it doesn't necessarily go through the same process. So this is illicit discharge detection is set in place to avoid those things. And so one of the plans that they encourage to put in place is ordinances. Construction site and stormwater runoff control includes requirements to control waste at sites. And then post-construction practices include strategies to implement a combination of structured and non-structured management practices. And pollution prevention, good housekeeping for municipal operators includes municipal activities like building maintenances, fleet maintenance, road repairs, street sweeping, and more. So this is an example of, this is pretty much the opposite of the first initial picture. So this is what the amount, 10%, so this is an example of what runoff would look like in an actual porous environment, a pervious environment, I should say. So of course 40% of the evaporation returns back into the atmosphere. And the reason for this returning back into the atmosphere, as you saw earlier, 30% returned into the atmosphere. And you may wonder why there is such a big difference. If you were listening earlier, I mentioned that the difference is because initially, when on pervious, non-pervious, which is the city area, runoff actually occurs a lot faster because the water has nowhere to go. Here, there's a slow drainage, so water actually sits in the area a lot longer. So this would be, this area right here would be our puddle, hypothetically speaking. So because it's really in a porous environment, it's slowly seeping back into the earth. So this is replenishing the groundwater table. And so everything else that's sitting here, it eventually either goes down into infiltrates into the ground, and 40% of it returns into the atmosphere because it's not moving. And so anything that's remaining slowly transitions over. And so the benefit of having plants in grassy areas and porous environments is trees and plants, roots all these different things actually filter. They're natural filters to water. When we actually carve out the ground and we actually remove the trees, we actually have no filter. So a lot of the pollutants that are traveling in urban runoff actually could possibly be filtered by the environment. And plants actually uptake these chemicals and these toxins, and they change them into a less harmful form. So managing runoff. Infiltration systems are an option to managing runoff. Infiltration systems are designed in such a way that they can trap runoff and then filter it into the ground. These systems provide efficient removal of suspended solids, particulate pollutants, coliform bacteria, organics, and some soluble forms of metals, and nutrients from stormwater runoff. The captured runoff increases groundwater recharge and the base flow in nearby systems. So that's pretty much stating that if this was a city area, they would have infiltration systems built into the ground. And so in that area, once the water seeps back through, they would filter it, which is something that I discussed just a couple seconds ago that plants normally do. Another option to managing runoff is to create a pervious paving system. So a pervious paving system will be something like so a pervious paving system is building maybe streets or towns and different things where, like, you know how they have cobblestone driveways and different things where water can actually seep back into the earth, so it's just not left to just sit on top of the surface. So something that homeowners can do is pretty much the same thing, having pervious paving systems. Instead of having a general concrete driveway, they can actually replace their driveway, maybe have a granite driveway, maybe have a stone driveway. So that's choosing an alternative to traditional paved surfaces and replacing high maintenance grass. Instead of having grass that requires excessive amounts of watering to thrive, replace it with something a little low maintenance. Another thing is sweeping the driveways, clearing the sidewalk of debris and different things. Instead of using fertilizers, they can use like leaves and bagged leaves instead of actually leaving them on the ground, or grass clippings. They can actually transitioning it to composting. One of the things that we've seen in parks is the little pet stations where you can actually use a plastic bag to pick up your pet poo. And that's something that we as people, general members of the public, can actually do. And also make sure a lot of us have cars and driveways. Sometimes it's the older cars, sometimes it's our newer cars and we don't even know it. Making sure you check your vehicles for leaks. So make sure that oil isn't spilling into the driveway, because oftentimes when oil spills into the driveway, we just kind of let it sit there. A lot of people don't really go through the measures to actually cleaning those oil spills up. And most of the time when we do clean the oil spills up, it usually is someone standing outside with the water hose rinsing it back into the environment. And then also have your septic tank. If you don't have a septic system that connects to a sewer system, if you just have a septic system in your backyard, one of the things that you can also do is actually have your septic system professionally inspected every 3 to 5 years, and also practice general water conservation methods. Some non-structural management ideas is for communities is street cleaning. We've seen that most recently with Hurricane Irma in Miami. Some municipalities had the street sweepers go by, and typically a lot of areas do have that, like Miami Shores. They typically have a street sweeper that drives by. And you also want to reduce the use of polluting substances. Oops. And also recycling waste and water, just using a recycling program. I'm sorry. Before it dies. Also, constructing impervious surfaces during urban planning, planting more trees, use land use planning and planning management strategies. So that's where urban planning comes in. So this image is an image of the National Management Measures Guidance to control non-point source pollution from urban areas. This is a comprehensive runoff management program. This model is developed, excuse me, the image is a model developed for comprehensive runoff management programs. It can serve as a resource for meeting national pollutant discharge elimination systems phase 2 requirements. Information in this document, and so this is just an image from a larger document. Information in this document is intended to provide technical assistance to state and local program managers on best practices and best available and most economically achievable means to managing urban runoff, starting at pre-development and ending at maintenance. So this is just a general framework and an idea of how to go about managing urban runoff. Whether this is a newer city or a newer development, it starts at conception and ends in just maintenance. So that is my presentation on urban runoff. I apologize about the freezing and hiccups and the low battery along the way.